Check if plane A and D are parallel or orthogonal or neither. Do it similarly for B and D and C and D. So with two planes, they are, suppose this is D, the plane we need to check with the three others. So D is parallel to A if the normal vector, this is the normal vector of D. If the normal vector of D is parallel to the normal vector of A, then two planes are parallel. They are orthogonal. So, for example, we have a light here on A, another light here on D. These two are orthogonal. So the normal vector of D and D is perpendicular to the normal vector of A and A. If these two vectors perpendicular, then the two planes are orthogonal. Plane A and plane D are parallel if the normal vector of A is parallel to the normal vector of D. They are orthogonal if the normal vector of A is perpendicular to the normal vector of D. To check whether NA is parallel to ND, we need to check if there exists a constant, say K, such that NA is K times ND. And to check if NA is perpendicular to ND, we check if the dot product NA dot ND is 0. NA and ND can be found from the equation of the planes. So for example, in this case, the normal vector of A, so here's the normal vectors and here's the plane. Normal vector of A denoted by NA is a vector -1 given by the coefficient of the x, y, and z. So in our case, NA is -4, and 0, because we don't have any z here. For the plane D, we have ND, the normal vector of D is -4 plus 4, 3. So look at the two, we can see that the two planes are perpendicular because NA dot ND is -4 times 4, 0 times 3. So we have plus 16 minus 16 plus 0. So this gives us A. The plane A is orthogonal to plane D. Plane B, normal vector of B is 4 minus 4 minus 3. So with the two normal vectors NB and ND, NB and ND, we see that NB is actually minus ND. So there is a scalar, there's -1, such that NB is minus 1 times ND. So this means that the two normal vectors are parallel. This means the plane B is parallel to plane D.